All right, in this video, we're going to take a look at the ways to classify reactions. And so far, we've got three what are called driving forces. So we have three driving forces or reasons a reaction occurs. Right? A driving force is a motivation. And so the three driving forces so far that we have are that, one, a reaction will occur if it will lead to a formation of a solid. A reaction can also occur if it will lead to formation of water. And a reaction will also occur if it leads to a transfer of electrons. Okay, electrons. So we have our three driving forces. Now let's take a look in particular at each type of reaction and see if we can give them a classification name. Okay, here is our first reaction type, and we see that this reaction is driven, the driving force is the formation of a solid. Okay, and so what we call this type of reaction, and there are two names for this type of reaction. The first we've talked about, so this reaction could be called a precipitation reaction. In a precipitation reaction, a solid is formed from two aqueous solutions. And at this point, you should have seen several precipitation reactions in class as we do them. As I'll do them as a demo to kind of show you what a precipitation reaction looks like. But this also has another name, and one that other chemists will use. And I want to introduce you to the name, and it's pretty easy to see here. What you have is if you look here, you have CrO4. Let me underline it here. And you have NO3. And if you look, these actually switch places. On the other side, the CrO4, the chromate ion, is now ionically bonded to the barium. Okay, and then NO3 is now ionically bonded to the potassium. They switched partners. In fact, it looks like this. If you had AB plus CD. Actually, let me do this in color for you. In color, the reaction looks like this. AB, right? AB plus CD. So C is the cation, D is the anion. And they switch places. Now it's AD and then CB. And this reaction has a name if that occurs. So you could call it a precipitation reaction if a solid's formed. But this is also commonly known as a double replacement reaction. So I don't want you to be left out at the chem party. Somebody brings up double replacement reactions, and you're like, well, I don't know. I only know precipitation. And I don't know why you would say that in a southern accent, but it's a chem party. Crazy stuff happens. But anyways, double replacement reaction is another name for that. So that's the first type. Okay? Let's take a look at the second type. Okay, here's our second type, and in this type of reaction, we have an acid and a base. This is the easiest to classify probably. And you can tell you have an acid because the compound starts with an H. And you can tell you have a base because the second compound ends in an OH. And the third telltale sign that it's a acid-base reaction is that water is also one of the products. Right? So you've got an acid and a base and you've got water. So this one is called, no big surprise here. I'm shocked. It's called acid-base reaction. And this is our second type. And that's the second driving force is the creation of water. Water is a stable compound. 70% of the world is water. It's very stable, and so it wants to form a stable thing. And so that's a driving force. So here's our third type of reaction. And there's a pattern to this type of reaction too. And you notice here, in this kind of reaction, which is called an oxidation-reduction reaction, you will have an element that has no charge forming a compound, which means it then must have a charge. And if it gains a charge or gains a positive or negative charge, that means it's either gained or lost or gained electrons. And so we see here we have zinc. I zinc it has no charge. And over here we see zinc, and I zinc its charge is +2. And I can tell because there's a 2 on the chlorine. Right? And so this is a oxidation-reduction reaction is how we label this. Anytime some of the elements in the compound gain or lose charge, and you'll look for a single element becoming a compound, it's oxidation reduction. So this is oxidation reduction reaction. But this also has another name, and I'll show you this here. If you look at this reaction, we could say this is A. See, what we could say here is that you have A plus BC, and that the B is replaced by the A. The A slides in, kicks the B out, and this form of reaction, which is oxidation reduction, also has a name. If it's A plus BC forms B plus AC, it is also known as a single replacement reaction. If you remember last slide, we had double replacement where two things are changing places. Here you have one thing changing place, so we can call this a single replacement reaction. Okay? And for now, that is how we're going to classify reactions. In the next video, I'm going to introduce 3 more types of reactions, and watch these videos as many times as you need, and take notes on the videos until you kind of understand the patterns with these reactions.